Hello, I'm Anna Mackay and today we're looking at exponential equations. So some of the terminology here. If a to the power of x is equal to a to the power of k. So we've noticed that the base is a and the powers or the exponents are x and k. What could that possibly be? What could that mean for x and k? What it means is that they would have to be equal. The only way that you could have the same base and they're raised to a particular power and be equal is if the powers are equal. There are some exceptions for that. We won't spend time on it now, but the exceptions are when a is positive or negative 1. We did look at that in a previous video of how that oscillates depending on the odd or even power and for 0. And so what that is telling us is that you must have the same base. That's the key component here. Getting into some examples here. We're solving for x. So what you're asking yourself is 2 to the power of x is equal to 16. So 2 to the power of what number gives you 16? Now these examples to start with are all with numbers that can be raised neatly to a power. So square numbers, powers to cube, powers, things like that. And eventually we get into things that can't be easily worked out, and that's where logarithms come in. But we'll get to that in our next set of videos. So the technique to do here is to recognise that we're looking for base 2. So you have to ask yourself, 16 is base 2 raised to what power? And hopefully you know it's the power of 4. And therefore, you equate the powers. So on the next line, you just write x is equal to 4. You don't need the bases anymore. You're equating the powers. And there's your answer. Next one. 3 to the power of a number plus 2 is equal to 1 on 27. So the technique for solving is get them equal to the same base. So what we do for the 1 on 27 is we recognise that that is 3 to the power of 3. We can then write that as equal to 3 to the power of negative 3. I'll actually just write this out a little bit more neatly. Let's put them equal on the same line. Now we can see the same bases are on the same level, therefore the powers must be equal, and we write therefore x plus 2 is equal to negative 3, and we rearrange by subtracting 2 off both sides, therefore x must be negative 5. If you want to check that, you can always substitute negative 5 back in here and go 3 to the power of negative 5 plus 2 and see if it's equal to that. Another one, 4 this time. Well, you might be saying to yourself, base 4, what could I do with the 8 for that? Well, you can't. It's going to be base 2 that you need to manipulate them both into. So 8 is 2 to the power of 3. Now the 4 hopefully recognises 2 squared. So we'll put that in a bracket to start with and put the x outside. But we really just want them as a base 2 and a base 2. So we need to manipulate the powers on this one. And the index laws with the brackets there tell us we can make it 2 to the power of 2x by multiplying those two powers together, the 2 and the x. Now we equate the powers, therefore 2x is equal to 3, so x must be equal to 3 on 2, and that's that one. This one here, 9 to the power of x take 2 is equal to 1/3. So you need to work them into the same base. Hopefully you're anticipating that the base will be 3. So this 9, we need to turn that into base 3, so we're going to go 3 squared, and we'll leave the other powers out there for the time being. And 1 over 3 is 3 to the power of negative 1. I guess in case you're not sure that that's the equivalent of 1 over 3 to the power of 1, and therefore you would rewrite it like that. Working out the left-hand side, 3x take, careful here, don't write 3x to the, 3 to the power of 2x take 2, it's take 4. The distributive law, you must multiply everything by that 2 there. And then we have is equal to 3 to the power of negative 1. Now you can equate the powers, and we have therefore 2x take 4 is equal to negative 1. 2x is equal to 3, and therefore x is equal to 3 on 2. Just as a side note, that you might have thought of doing this in a different way. You might do it this way round, where you multiply the bracket in this way, so not expanding it out, so to speak, and then you equate powers. And then the next step that you might do is, instead of expanding the brackets, you might divide both sides by 2 to get x take 2 is equal to negative 1/2, and then add 2 to both sides, but you'll still get the same answer of 3 on 2. So provided your algebra is correct, you can do it in a couple of different ways. This one here, last one, and the tricky one. So you might be thinking, okay, looks like it might be base 2. I could turn that 4 into that, but the 20, I'm not sure about that. And then the rule is you basically have to have one thing either side of the equals. That's sort of 2 terms. Well, you've got 3 here. So you need a new technique. The technique we're introducing is essentially a quadratic within these exponents. So if a, we'll just make up this a here, if that was equal to 2 to the power of x, let's see if we could write that equation in terms of these a's. Well, the end is equal to 0, that's fine, the negative 20. The middle term, okay, let's make that a. Well, what would this first term be then? Well, think about it. I'll do another side note over here. You've got 4x. Let's write that as 2 squared x. And as we know from previous work, you could also write that as 2x and the 2 out there. So that 2x, well, that helps us because that's our a. So that could be equivalent to a squared. All right, well, let's put that back up in there. So this is a different way of writing this equation here by identifying what a is. Now that's a quadratic. Can we solve that quadratic? I think we can. Factorising that, looking at factors that of a and c, you know, where we've got a, b and c concept there. What multiply together to give this negative 20? Well, we're putting an a here and a here. We've got a 4 and a 5. And do we want positive or negatives? We have to end up with a coefficient of positive 1. So if we have a positive 5 and a negative 4, we should be right. And so now what we do is we actually go back, and where we see an a, we're going to substitute in a 2x. And let's write that over here. So where we had an a, we're going to write 2 to the power of x, Same on both sides. And we've got take 4 and plus 5. Out, and that's all equal to 0. So that's our technique there. As you get better at this over time, you can move straight to, you might think of it like this, the 2x squared, you'll be able to recognise that the plus 2x take 20 is equal to 0. And from that, you'll get faster at factorising straight into this form without having to go into this form, but it's always very handy to know where it comes from. Now we're using the null factor law to equate that. So we've got 2 to the power of x is equal to 4, or 2 to the power of x is equal to negative 5. And here's a new fact about exponentials, that they're all greater than 0. So if you were to graph this, 2 to the power of x, you will see that it's always greater than 0, which means the y coordinates are always above 0. Because you think about this, you're saying 2 to the power of what number gives me negative 5? So 2 to the power of positive numbers is going to give you a positive answer. What about 2 to the power of negative numbers? Well, you think about that. 2 to the power of, just do a side note, 2 to the power of negative 2, for example, is the same as 1 on 2 to the power of 2, which is 1 on 4. And that's still a positive number. So even when you substitute in negative powers for x, negative numbers, the answer is still going to be positive. And so that's where this statement holds, is that 2 to the power of x will always be greater than 0, always be a positive number. So whenever you get a scenario like this, where it's equal to a negative number, it can't happen. So we can discard that answer there, and we just have to deal with the positive answers over to the left here. And so now back to the techniques of solving, put them equal to the same base and equate the powers, and therefore we're left with x is equal to 2. Well done. Join me in the next video, exponential functions. Subscribe to the channel. Thank you.